All right, we're going to continue on with then our next lecture, and this is 4.3b. All right, we are in the same essential standard, except we are going to learn how to divide using synthetic division our polynomial expressions. Synthetic division is a shortcut method for dividing a polynomial by something such as an x minus c. This division method minimizes the work by focusing just on the relevant numbers as shown to the right. Be careful if a term is missing, such as, let's say you don't have an x squared term, you must put a 0 in there to represent the missing term. Don't worry, we'll practice that. What does all this look like? We see that we have all of these, the 6x cubed minus 25, etc. All of those coefficients show up in this location here. Then we have this x minus 3. This is where we switch the sign of the 3 and it shows up right there. If you notice the answer in this long division problem, we have 6x squared minus 7x minus 3. Here is where those coefficients will end up showing up in our synthetic division. And we have a remainder of 0, and this will be where our remainder is. It is important to note that this is a lot less work than long division. So that should be encouraging to you. This is a reference for you, and you can read through this if you need to review back. We're not going to step through it because I think once we work through our examples, it will make more sense. So let's do some examples. Divide using synthetic division. Okay, so what we're going to do is we are going to construct a box, and we will then take the coefficients of the this 2x cubed minus 13x squared, etc. And we will, that'll be our numerator. So this is 2. We have a minus 13. We have a 26, and we have a a negative 24. Okay. Now notice that I have an x cubed, I have an x squared, I have an x to the 1, and technically this is x to the 0. I do not have to have any placeholders for that. I am then going to switch the sign of that negative 4 and put a 4 there. The first step is to carry this 2 straight down and bring it down. Next thing you're going to do is multiply your 4 by the 2 and bring it to this location, and I get 8. Now we're going to add negative 13 plus 8, and we will get negative 5. Then we will take 4 times our negative 5, and we will get negative 20. And then we add 26 plus negative 20. We get a 6. Then we multiply again that 6 by 4, and we get a positive 24. We will add negative 24 plus 24. We get 0. This becomes our remainder. This is our x to the 0 term. This is our x to the 1 term. This is our x squared. Notice our answer has 1 degree less than we started, which is what we would expect. So our answer will be 2x squared minus 5x plus 6 with a remainder of 0. A lot less work, is it not? All right, let's continue and do another one. So here is my terms that I need to divide by a plus 3. I have a cubed, a squared, 1 to the 1 power and 1 to the 0 power. I do not need any placeholders. 2, 3, minus 4, and 15. Switch the sign. So I have a negative 3. Bring the 2 down. Bring the 2 down. Okay, multiply negative 3 by 2, I get a negative 6. Add 3 plus negative 6, I get a negative 3. Multiply negative 3 times negative 3, positive 9. Add negative 4 and 9, I get a positive 5. Add negative 3 multiply negative 3 times 5, I get a negative 15. Those add to 0. This is my remainder. This is my a to the 0 term, which is, this is my a to the first term, and this is my a squared. I have, my final answer has one less degree than the original polynomial. So my answer will be 2a squared minus 3a plus 5 with a remainder of 0. Okay. All right, why don't you try one yourself? Please pause the video and try this yourself. Welcome back. So what do we get? I have 3. I have a -8. I have an 11. And I have 14. I don't have to have any placeholders. To the cube, squared, first, to the 0. I take, oh, that's what I got, where I got those coefficients. I take this -2. I switch the sign. I carry the 3 down. I multiply 2 times 3, I get 6. I add them, I get -2. 2 times -2, -4. Add them, I get 7. 2 times 7 is 14. Okay. Oh, I forgot my negative up there. -14 plus 14 is 0. This is my remainder right here. This is my m to the 0, m to the 1, and m squared. So my answer will be 3m squared minus 2m plus 7 with a remainder of 0. Okay. All right, let's do another one. All right, we have, this is my term. Create my box. I have a to the 4th. I am missing a cubed. So what do we do by that? What do we do? We have 4. We have 0. I need my placeholder for my x cubed term. Then I have a 2x. Oops, I don't need the x part, do I? Okay, keep continuing on. So 2 for my x squared term. Then I have a -4 for my x to the 1. Then I have a +12 for my x to the 0. Then I take my +2 and I switch the sign. So I have -2. I bring down my 4. And then I multiply by -2 and I get a -8. Very important that you have a placeholder there for the x cubed. You will get it wrong if you do not have a placeholder for that. So essentially, we have 0 times x to the cube. Okay. Okay, 0 plus -8 is -8. -2 times -8 is a +16. I add them. -2 times 18 is a -36. Added together gives me -40. -2 times -40 gives me a +80. 80 plus 12 gives me 92. This is my remainder. This is my x to the 0, x to the 1, x squared term, x cubed term. So what does my answer look like? 4x cubed minus 8x squared plus 18x minus 40 plus my remainder. What is my remainder? 92 over x plus 2. This, I have to divide it by the original one that the original polynomial that I was dividing by. That is my remainder. There's my answer. Okay. All right, why don't you try one? All right, welcome back. First thing I would notice is I have 4th, the cubed. I am missing I have a 0 times my bx squared term. So I've got to have a placeholder. I have b to the 1st power, b to the 0 power. So I got to create my box. I'm going to have all my coefficients here. So my 6 is to my 4th. My -8 is to my 3rd. My 0 is to my squared. My 12 is to my b to the 1 power. And then negative 53 is to the b to the 0 power. I take my negative 2, I switch the sign. I take my 6 straight down, and I start multiplying. 2 times 6 is 12. Negative 8 plus 12, 4. 2 times 4, 8. 0 plus 8, 8. 2 times 8, 16. 12 plus 16, 28. 2 times 28, 53. Oops, sorry, not 53, 56. Negative 53 plus positive 56, 3. This is my remainder. This is my b to the 0, b to the 1, b squared, b cubed. Notice I'm 1 degree less than I started, which I should be. So what is my answer? 6b cubed plus 4b squared plus 8b plus 28, and I have 3 over b minus 2 as my remainder. Okay. All right, so now we have a situation where we have to address when we don't have an x plus or minus some number, okay? If a polynomial is being divided by a linear factor such as 3x minus 5, so now I have some constant in front of my linear term, synthetic division does not work. We have two choices in that situation. We can divide by using long division or divide by the numerator and denominator by this coefficient on the x term such that, and if we do that, we can then use synthetic division. Sounds like it's recommended to use the long division in this situation, but since we're doing synthetic division, we will show you how to do it with this process. So what does that mean? So what we need to do is we need to divide both the numerator and the denominator by 3, every term by 3. We're going to divide every term by 3 so we can get rid of that 3 in the coefficient on that x term there. So I'm going to divide everything by 3 and everything by 3. And so what is that going to give me? So in the numerator, I'm going to divide 3x to the 4th by 3, and I will get x to the 4th. I'm going to divide negative 5x cubed by 3, and I'll get negative 5/3 x cubed. I will get 1/3 x squared. I will get 7/3 to the x power. Then on the denominator, I will get x. Now I have what I want, plus 1/3. And then I will start my synthetic division process. So I will draw my box, write my terms. I have 1 for my x to the 4th, minus 5/3 my x to the 3rd, 1/3 for my x squared, 7/3 for my x to the 1 power. And notice I don't have a coefficient, which is my x to the 0 power, so I have a placeholder 0. I will then take this positive 1/3 and switch the signs, and I now have a negative 1/3, and I will start this process. I bring down my 1, I multiply by negative 1/3, I get negative 1/3. I add the 2 together, negative 5/3 plus a negative 1/3 gives me a negative 6/3. That is the same as negative 2. I then multiply negative 2 by negative 1/3. That gives me a positive 2/3. Add a third plus a positive 2/3 gives me a positive 1. Multiply 1 by negative 1/3, get a negative 1/3. Add 7/3 plus a negative 1/3 gives me 6/3. That reduces down to 2. Multiply positive 2 by negative 1/3, I get a negative 2/3. Add 0 plus a negative 2/3 gives me a negative 2/3. This is my remainder. Okay, and this is my x cubed term, x squared, x to the 1st, x to the 0 power. So I can write my answers. So I get x cubed minus 2x squared plus x plus 2. And then I have this remainder, plus negative 2/3 over. And what did we divide by? We divided by x plus 1/3. Okay. Now, this situation, that is an acceptable answer, but in the back of the book, that's not how they're going to show it to you. They would have reduced this by multiplying through that remainder by the constant 3 so that I can get rid of the fractions, and this would be what it looks like. And I would get negative 2 divided by 3x plus 1. All right, why don't you try one yourself? Okay, welcome back. So now what I need to do is I'm going to have to get rid of this 2. I'm going to have to divide every single term on the numerator and the denominator by 2. So 8x to the 4th divided by 2 gives me 4x to the 4th. Then negative 4x squared divided by 2 gives me 2x squared. I have x term that I have to divide 2 by, so I get a positive 1/2 x. I have a positive 4 I need to divide by 2, and I get positive 2. Divided by, and then I get x plus 1/2. So I've divided every term by 2. Now I am in a situation where I have no constant in front of my x, and I have a format that I can use, synthetic division. So let's go ahead and do that. Actually, that was a little bit aggressive. Let's see if I can do that here. Here we go. I'm going to take every one of these terms, and I have a 4 for my x fourth. Notice I have nothing. I have no x cubed. I have 0x cubed, so I need a placeholder. I have negative 2 for x squared. I have 1/2 x to the first, and I have 2 for x to the 0. I will then take this 1/2, change the sign, I will have negative 1/2. I will bring down my 4, and I multiply by negative 1/2, I get a negative 2. Add those together, multiply by negative 1/2 gives me a positive 1. Negative 2 plus positive 1 gives me a negative 1. Multiply by negative 1/2 gives me a positive 1/2. 1/2 plus 1/2 is going to give me a positive 1. Negative 1/2 times 1 gives me a negative 1/2. Now I have to add 2 plus negative 1/2, have to use a common denominator, and that will simplify into positive 3/2. This right here is my remainder. Okay, this is my x to the 0, x squared, x cubed. Wait a minute, what did I do wrong? Oh, I see what I did wrong. Forgot my x to the 1 term. X squared, x cubed. Sorry. All right, now I can write my answer. I get 4x cubed minus 2x squared minus x plus 1, and plus my remainder, which is 3/2 divided by x plus 1/2. I can simplify that by multiplying through by 2. So I will get 4x squared minus 2x squared minus x plus 1 plus, if I multiply both the top and the bottom by 2, I will get 3 over 2x plus 1. And that would be your answer. Okay, 2 SAT style questions that are related to this. Why don't you try them yourself? Okay, welcome back. So essentially, what do we get? So if I take the numerator here, I have a 5 and a negative 2, and I will switch the sign, and I will have a -3. I bring down the 5. -3 times 5, -15 gives me -17. That is my remainder. 5 is my x to the 0 term, and here is the answer. How about the next one? I have a 1, a -2, a -5. I will switch the sign here. I will have a +3. I will bring down the 1. I will get a 3. I will have a 1. I'll get a 3. I'll get a -2. -2 is my remainder. This is my x to the 0, x to the 1, and you will see your answer right here. All right, that's where we are at this time. Reach out to me if you have any questions.